So imagine looking on the horizon and sunrise is half the sky.
Ever wonder what it would be like to see a star explode? Could we really see it from Earth? And when is this big event supposed to happen? Betelgeuse, one of the largest stars in our galaxy, is gearing up for just such a grand finale. It's going to explode into a supernova, and when it does, it's going to light up our night sky like nothing we've ever seen before. So when can we expect this star-studded spectacle? Stay tuned to this video as we unravel the mystery of when Betelgeuse will go supernova. So Betelgeuse is a one-of-a-kind star in our night sky. It's what we call a red supergiant. Supergiant stars are among the most massive and luminous stars out there. They're much larger and shine much brighter than our own sun, and they burn out their fuel much quicker. Now, when we call Betelgeuse a red supergiant, it's because it's cooler than other stars, which can be blue or white. The color of a star tells us about its temperature, with blue being the hottest and red being the coolest. Where can you find Betelgeuse? It's part of the Orion constellation, which you might know as the Hunter. Orion is one of the most recognizable constellations. If you look for Orion's belt, which is made up of 3 stars in a straight line, Betelgeuse can be found just above it, marking one of Orion's shoulders. Now, in terms of brightness, Betelgeuse is usually the 10th brightest star in the sky, although its brightness can change. It's a variable star, which means that its light doesn't stay the same all the time. Sometimes it gets brighter, sometimes dimmer. In fact, it has the widest range of brightness compared to any other first magnitude star. Magnitude is just a fancy term for how bright a star appears from Earth. So even though Betelgeuse is very, very far away, it can still shine incredibly bright in our sky. And for a fun fact, the name Betelgeuse comes from Arabic. It translates to the giant's shoulder, which is quite fitting considering it's placed on Orion's shoulder. Its official astronomical name is a bit more boring though. It's known as Alpha Orionis, or Alpha Ori for short. This is based on the Bayer designation, a system used by astronomers to name stars. Alpha means it's the brightest star in the constellation, even though in Betelgeuse's case, it's often outshined by Rigel, another star in Orion. Betelgeuse, as we mentioned before, is a red supergiant. But what does that really mean? Well, its red color comes from its cooler surface temperature, which is around 3,600 degrees Kelvin. That might still sound pretty hot to us, but in terms of stars, that's pretty cool. Now, even though it's cool, Betelgeuse is still extremely bright. It's one of the most luminous stars in our galaxy, shining about 126,000 times brighter than our sun. Now, one of the fascinating things about Betelgeuse is that its size isn't constant. It actually changes because the outer layers of the star pulsate due to pressure waves. This pulsation causes its radius to vary between 702 and 880 times that of the Sun. To put that into perspective, if you imagine the Sun as the size of a basketball, Betelgeuse would be as big as a football stadium. If we were to place Betelgeuse in the center of our solar system, it would be so large that it would extend beyond the orbit of Mars and possibly reach the asteroid belt. When we talk about the distance from Earth to Betelgeuse, things get a bit tricky. There are different ways to measure the distance to stars, and different methods give different results. The most recent estimate, based on measurements by the Gaia satellite, is around 548 light-years away from us. But this comes with a level of uncertainty, so it could be closer to us or further away. This means that the light we see from Betelgeuse today actually left the star around the year 1473 CE. Other estimates range from 427 light-years to 724 light-years away. That's quite a range. Betelgeuse might be far away, but it's so big that it has an angular diameter, or apparent size from Earth, that can be seen by some telescopes. Betelgeuse was actually the first star, other than the Sun, to have its surface imaged by a telescope. Since that first image was taken in 1920, astronomers have been able to observe spots, plumes, and asymmetries on Betelgeuse's surface. One of the most fascinating things about Betelgeuse is that it's a variable star. This means its brightness can change significantly over time. In early 2020, Betelgeuse dimmed to about 40% of its usual brightness. This sudden dimming got a lot of people excited, thinking that it might be about to explode into a supernova. So, is this red giant nearing the end of its stellar life? In the grand scheme of things, which in the case of stars is a timeline of millions or billions of years, Betelgeuse is expected to go supernova, which means it will explode within the next 100,000 years. It might seem far off to us, but on a cosmic timescale, it's just around the corner. And believe us, when that happens, it's going to be an absolute spectacle for anyone on Earth lucky enough to see it. Now you might be wondering, what exactly is a supernova? Well, when we're talking about cosmic events, a supernova is the greatest of them all. It's the most powerful explosion that humans have ever seen. Every single one of these blasts represents the spectacularly bright, insanely powerful explosion of a star. This kind of event takes place during the final stages of the life of a massive star, or when a white dwarf or another type of star is triggered into runaway nuclear fusion. The result? The original star, also known as the progenitor, either collapses into a neutron star or black hole, or it gets completely blown apart, forming a nebula, which is a giant cloud of dust and gas. Supernovae come in two main flavors, Type 1a and Type 2. Now don't let these simple names fool you. There's a lot going on behind the scenes here. In a Type 1a supernova, it's all about balance, or rather, what happens when balance is lost. It happens in binary systems, which is a fancy way of saying two stars orbiting around each other. In this case, one of these stars has to be a white dwarf. This white dwarf can either steal too much matter from its companion star, or it can merge with another white dwarf. In both scenarios, the white dwarf can't handle all this new matter and becomes unstable, causing a thermonuclear explosion that completely destroys the star. On the other hand, a Type 2 supernova is all about running out of fuel. This event happens when a star, at least 5 times the mass of our Sun, exhausts its nuclear fuel. Without fuel, the core of the star collapses under its own gravity, becoming a neutron star or a black hole. The outer layers of the star, meanwhile, get blown away in a powerful shockwave. So going back to Betelgeuse, as a red supergiant, it's expected to go out in a Type 2 supernova when it's done burning its fuel. That event is going to be something to behold. The explosion will likely shine brighter than the full moon and be visible in broad daylight. You see, our star of the hour, Betelgeuse, is a heavyweight, with a mass about 15 times that of our Sun. Over millions of years, it's been performing an incredible cosmic alchemy. In its core, Betelgeuse has been fusing hydrogen and helium, the lighter elements, creating heavier elements like carbon, oxygen, silicon, and eventually iron. Now, iron is a bit of a party pooper in the world of stellar fusion. It's the most stable element, meaning it's very difficult to squeeze anything more out of it energy-wise through fusion. And in the star business, if you're not fusing, you're not producing the pressure needed to counterbalance the star's gravity. Now this brings us to the fate of Betelgeuse. When its core gets crammed with iron and can't create any more energy, it becomes unstable. The star's gravity wins over, causing the core to collapse in less than a second. This core collapse releases an astronomical amount of energy, so much so that it generates a shockwave. This shockwave is like an intense, powerful surge of energy that races outward through the star. As it moves, it heats and compresses the star's outer layers, causing them to explode. This dramatic explosion is what we would see as a supernova, a brilliant display of light and radiation that outshines an entire galaxy. But the spectacle isn't just about the light show. The shockwave also acts as a cosmic forge. As it hurls the outer layers of the star into space, the intense conditions trigger nuclear reactions that create new elements, including ones heavier than iron. Some of the gold, silver, and uranium on Earth actually originated from ancient supernovae, just like the one Betelgeuse will eventually become. After the fireworks die down, we're left with the core. The core's destiny, whether it becomes a neutron star or a black hole, depends on its mass. A neutron star, like its name suggests, is a superdense object composed mostly of neutrons. Imagine cramming 1.4 times the mass of the Sun into an object about the size of a city, and that is a neutron star. These celestial bodies are truly extreme in their density. On the other hand, if the core is massive enough, it could continue collapsing to form a black hole. Black holes are the champions of density and gravity. They are so dense and their gravity is so strong, nothing can escape them, not even light. The death of this star is going to be a fantastic cosmic event, beyond just being a dazzling light show, which also contributes to the cycle of matter in the universe as it creates and spreads heavier elements across space. We will be in for a real treat on Earth when it happens. Because when the day arrives, Betelgeuse will certainly go out with a bang. Despite being hundreds of light years away, the sight of Betelgeuse going supernova will be nothing short of spectacular due to its relative closeness in cosmic terms. First off, the explosion will be so brilliant, for a while, Betelgeuse will outshine every star in the night sky and be visible during the day. Imagine that. A star so bright, it can cut through the sun's glare. It will hold a luminosity rivaling a half-moon for over 3 months. For those months, our sky will have an additional, prominent light source. That's how bright and powerful the supernova will be. Then, alongside the light show, the supernova will emit a spectrum of radiation, from gamma rays and X-rays to ultraviolet, infrared rays, and radio waves. This sounds a bit scary, but don't worry. The distance between Betelgeuse and Earth acts as a shield. Even though these emissions will reach our planet, they won't cause harm to life here. Our atmosphere does a good job protecting us from such cosmic radiation. Now, as the star explodes, it will also release neutrinos. These elusive particles, almost ghost-like, rarely interact with matter, meaning that they can zip through practically anything. In fact, trillions of neutrinos from the Sun and other cosmic sources are passing through you right now, unnoticed and harmless. From a scientific perspective, these neutrinos from Betelgeuse's supernova will be of immense interest. They could offer new insights into the inner workings of a collapsing star, providing priceless information about these cosmic events. In the aftermath of the explosion, Betelgeuse will leave behind a gorgeous nebula, a supernova remnant. This will be an expanding, glowing cloud of gas and dust, a kind of celestial masterpiece painted with radiant hues reflecting its temperature and composition. And this isn't just about the beauty. These remnants are key players in the cosmic cycle of life. The shockwaves they generate, as they expand and interact with the interstellar medium, can trigger the formation of new stars. For astronomers and astrophysicists, the supernova of Betelgeuse will be akin to the Super Bowl, the Olympics, and the World Cup rolled into one. It's a rare opportunity to study the physics and chemistry of stellar explosions in detail, enhancing our understanding of these celestial events and their role in shaping the universe. For the rest of us, we won't need a fancy telescope to appreciate it. This celestial firework display will be clearly visible to the naked eye. On top of that, the red supergiant has some tricks up its core. For instance, it doesn't maintain a steady glow like many other stars. Instead, its brightness varies over time. 2 main periods of variation have been identified. One lasts about 425 days, and the other spans roughly 6 years. In addition to these, Betelgeuse has irregular fluctuations in its brightness that we don't quite understand yet. The year 2019 brought an unusual event for Betelgeuse. Late that year, the star started dimming in a big way. Its brightness kept decreasing until it reached a low point, an apparent magnitude of 1.6 by early 2020. For a star that's usually one of the brightest, this was a significant drop. This dramatic event was aptly named the Great Dimming. However, like a cosmic phoenix, Betelgeuse returned to its original brightness later that same year. So what caused this great dimming? Astronomers believe it was due to a large amount of gas ejected by Betelgeuse. When this gas cooled, it turned into dust. This dust cloud effectively obscured light from about a quarter of the star's surface, causing the star to appear fainter from our perspective on Earth. The Great Dimming caused quite a stir, both among astronomers and the general public. The significant dimming of such a prominent star led to speculations. Some people wondered if Betelgeuse was about to go supernova, which would result in a massive explosion visible even during the day. But experts mostly agreed that this was unlikely. Despite its size, Betelgeuse is still relatively young for a red supergiant. It hasn't burned through all of its nuclear fuel, a condition necessary for the supernova process. Yet, the Great Dimming wasn't just about speculation and public excitement. It offered an invaluable opportunity for scientists to study the structure and evolution of Betelgeuse, a star known for its complex dynamics. With the help of various telescopes and techniques, astronomers could observe Betelgeuse's surface, atmosphere, and surrounding environment in unparalleled detail. And there is more to its environment. Betelgeuse is a cosmic behemoth, and it certainly has an environment to match. Over its lifetime, this red supergiant has been steadily releasing layers of gas and dust. This continual ejection has formed an intricate, dynamic envelope surrounding the star. Let's dive deeper into the details about Betelgeuse's cosmic neighborhood. Betelgeuse is literally shedding weight, losing mass at a staggering rate. How much, you might ask? About 1/millionth of a solar mass every year. In more familiar terms, Betelgeuse loses the equivalent mass of Earth every decade. This mass loss is propelled by potent stellar winds that push away the star's outer layers. The force of these winds is likely ramped up by the magnetic fields and pulsations in the star's atmosphere. The material being expelled from Betelgeuse doesn't just float off into space aimlessly. It forms structures like shells and arcs, extending up to 7.5 light-years from the star. These aren't invisible either. We can observe them at infrared and radio wavelengths. They glow with their own light, heated by Betelgeuse's radiation. Some of these shells date back as much as 100,000 years, while others are more recent additions. Zoom in a bit closer to Betelgeuse, and you'll find its immediate surroundings, within about a light-year of the star, looking much brighter than regions further out. This is likely due to an increase in the star's mass-shedding rate that started around 30,000 years ago. The structure of this inner envelope around Betelgeuse isn't symmetrical, suggesting that the star hasn't been ejecting material uniformly. A particularly intriguing feature within Betelgeuse's inner envelope is a bright spot that might be a plume or even a companion star. First detected by the Hubble Space Telescope back in 1995, this spot, located about 0.1 light-years from Betelgeuse, has a temperature of about 1500 degrees Kelvin. There's a bit of a mystery surrounding its origin and nature. The spot could be related to magnetic activity or convection on Betelgeuse's surface, but for now, it remains a cosmic enigma. Betelgeuse's local environment isn't just shaped by the star's own activities, but also by its motion through space. Betelgeuse is zipping through the cosmos at a speed of about 30 kilometers per second relative to the surrounding interstellar medium. This creates a bow shock in front of the star. The bow shock phenomenon is a type of shock wave that occurs when a supersonic flow encounters an obstacle, such as a planet, a comet, or a star. The obstacle deflects the flow and creates a curved wavefront that stands off from the obstacle surface. This bow shock is a region where the stellar wind from Betelgeuse collides with the ambient gas and dust. The shock wave spans about 4 light-years and reaches temperatures around 10,000 degrees Kelvin. So, from its ongoing mass loss to its asymmetrical inner envelope and the intriguing bright spot, Betelgeuse continues to be a subject of fascination and study. As we learn more about Betelgeuse and its cosmic neighborhood, we're reminded of the mysteries and wonders that lie beyond our planet. So, what do you think about all of this? Let us know in the comments, and we'll see you next time.